Welcome to qnawire.
In this question, we are given a machine with 4 gears, whereby gears A and B are in mesh. B and C shares the same shaft. Gears C and D are in mesh. So we are given that omega A is as a function of theta is given as such, theta A plus 1, where theta A is the angular displacement of A. And then we want to determine the angular acceleration of gear D when theta A equals to 3 radians. Okay, so we'll be using this expression alpha d theta equals to omega d omega. Okay, so alpha A d theta A is omega A d omega A. So substitute what omega A is. So omega A is theta A plus 1, and then d omega is d of this, so it will be d theta A. Then if you compare both sides, you see that alpha A will be equal to theta A plus 1. Okay. So next, when theta A is 3 radians, alpha A will be 4 radians per second square. Okay. Yeah, so because we want to find the angular acceleration of gear D, that we need to find the angular acceleration of gear A first. Okay, so so gears A and B are in mesh. So that means that alpha B RB equals to alpha A RA. That means alpha B is equal to RA over RB times alpha A. Putting in the numbers, RA is 15 mm, RB is 50 mm, and then alpha A is 4. So this is 1.2 radians per second square. Okay. Then B and C share the same shaft. So which means that they are going to rotate together with the same angular accelerations. A alpha C equals to alpha B equals to 1.2 radians per second square. Okay, then C and D are in mesh, which means that alpha D RD equals to alpha C RC. So alpha D is RC divided by RD times alpha C. So putting in the numbers, 25 over 75 times 1.2. So this is 0.4 radians per second square. Okay, so this is the final answer of for the angular acceleration of gear D.